Algebra 1, Chapter 3, Section 6, Proportional and Non-Proportional Relationships. So a proportional relationship is always of the form y equals kx, and of course k can't equal 0 because then it's really boring. It's just y equals 0, and that's not an interesting problem at all. You can see this looks just like direct variation, right? There's not really that much of a difference there. Uh, because it's of this form, it's always going to go through the origin, but it makes a nice straight line. And you can see that in the little example graph that they have here. Goes through the origin, has a straight line. The k value is the same as the rate of change, is the same as the slope. Um, and if you take a look at the table of values here, it goes up by 1 each time, and the table of values, and the output goes up by 3 each time. So we have a rate of change of 3 over 1, which is the same as the k value. All right. Now, with that in mind, what we're going to do is we're going to graph this, which is not any different than graphing the direct variation kind of problem. We're just going to have to figure out what the rate of change is. So Marco is a personal trainer at a gym. In addition to his salary, he receives a bonus for each client he sees. This is pretty common. I actually have a friend who used to work at a gym in Santa Rosa, and I think he works on one in LA now. And the more clients you got, the more money he made. But he also was just like wandering around helping people out if they needed it. So you can see here the clients go up by 1 each time. And it looks like it goes from 45 to 90. That's plus 45, plus 45, plus 45 again. Yeah, it looks like we have a rate of change here of $45 for every one person that they have a client for. I guess I would say one client here. All right. So that tells me my k value is 45, and let's write the equation here. Y equals, oh, actually, that's the next part of the problem. We'll hold off on doing that. Let's go ahead and graph this data here. Now again, it goes up very fast for the bonus pay. So we're only going to put a couple of things down for the client axis. 1, 2, 3, 4, 5. But for the bonus pay axis, bonus pay, we're going to have to go up by more. I'm going to go up by, well, we could be really nice and easy and go up by 45 each time, right? Because that's what the slope is. Most of the time you might choose 100 or go up by 50 each time, maybe by 20. But now I know, if I know that the rate of change is $45 per client, I might as well go up $45 at a time. So 90, 135, this is 180 up here, 225, and then up to 270 up here. Now I can plot my points. One client, $45. Two clients, 90. Three clients, 135. Four clients, 180. And five clients, 250. And there is my data graphed on a table. Oh, I should put down number of clients. All right. Now, we're going to write our equation, and that's where this k value equals 45 really comes in handy. I'm just going to substitute it into y equals kx. So it tells me my equation for this relationship is y equals 45x. All right. Yeah, and that's all we need to do for this problem here. So it's just plotting the points down, putting it in. You can add in a line if you want to. We're not really going to worry about that too much yet, but that's going to be the next problem where we're going to look at stuff with a line. But you could draw a line in there, go through the origin, and then all the points. And there's my line for the graph.